You hear these terms thrown around all the time, right? AI, machine learning, deep learning. A lot of the time, they're used like they all mean the exact same thing, but, well, they don't. So today we're going to cut through all that noise and lay out exactly what each one is, and more importantly, how they all fit together.
So let's get right to it. What is the real difference between these things? We're going to break it down, step by step, so that by the end of this, you'll see the whole picture crystal clear.
All right, let's start at the very top. We've got to begin with the biggest, oldest, and broadest idea of them all, artificial intelligence. You know it as AI. At its heart, AI is really the grand vision, the big dream. It's this huge field of computer science that's dedicated to one single massive goal, building machines that can think, learn, and reason just like we do. It's the foundational concept that started everything.
You know, the best way to picture this whole relationship is to think of those Russian nesting dolls. AI is the biggest outermost doll. It's the whole field, the big idea that got its start way back in the 1950s. Now you open that doll up, and inside you find the next one, machine learning. And then, nested deep inside that one, you find the smallest, newest, and arguably most powerful doll of them all, deep learning.
And you're probably using AI way more than you even realize. I mean, think about it. Your phone unlocking just by seeing your face. That's AI. Asking your smart assistant about the weather? That's AI. An online store is suggesting a product you might actually want to buy. Yep, all of these are powered by the broad principles of artificial intelligence.
Okay, so if AI is the big dream, the big what, then how do we actually do it? Well, one of the most important answers to the how is machine learning.
So, machine learning, or ML, isn't a separate thing. It's a specific approach to making AI a reality. Here's the key idea. Instead of trying to write explicit step-by-step instructions for every single possible task, we build systems that can learn on their own, just by feeding them a ton of data. It's really the science of getting computers to act without being explicitly programmed.
So how does that work in practice? Well, you basically feed a machine learning model a massive amount of data. Its algorithms then just chew on that data, hunting for patterns and connections. And once it finds those patterns, it can make incredibly accurate predictions about brand new data it's never seen before. But here's the crucial part. The more data you give it, the smarter it gets. It's constantly improving.
Your email spam filter is just a perfect classic example. Nobody programmed it with a giant list of every possible spam word. Nope. It learned to identify junk mail by analyzing millions and millions of emails. And it's the exact same thing with Netflix. It learns what you like to watch, and then it predicts what other movies you might enjoy. That's ML in action.
Now, machine learning was a huge, huge leap forward, but it had one really significant bottleneck, a limitation that required a whole lot of human effort to get things working.
And that limitation has a name: feature engineering. Let's say you wanted to teach a traditional ML model to identify a cat in a photo. Well, a human programmer had to sit down and manually tell the model what features to look for, things like pointy ears, whiskers, a long tail. You can imagine this was incredibly slow, and it really limited the complexity of problems that ML could solve on its own.
And this is where the next revolution comes into play. To get past that human bottleneck, to get around the limits of feature engineering, researchers developed a much more advanced, much more powerful subset of machine learning. And that is deep learning.
See, deep learning takes this idea of learning from data and just cranks it up to a whole new level. It does this by using these really complex structures called artificial neural networks, which are, just as the name suggests, directly inspired by the interconnected web of neurons inside the human brain.
And here is the absolute magic of deep learning. It gets rid of the need for that manual feature engineering completely. You don't tell the model to look for pointy ears to find a cat. Instead, the neural network figures out the most important features all by itself. It might discover patterns a human programmer would never even think to look for.
The way it learns is just fascinating. So information flows through all these layers of artificial neurons. The network then makes a guess, a prediction. It'll say, okay, I think this is a cat. Then it checks its guess against the right answer. If it's wrong, it goes back and actually adjusts the strength of its internal connections to make a better guess next time. It repeats this cycle millions, even billions of times. And in doing so, it literally teaches itself how to see and understand.
And it's this self-learning ability that unlocks applications that honestly feel like science fiction. We're talking about tasks that require a real kind of perception, self-driving cars that have to navigate a chaotic street, real-time language translation, or even AI that can look at a medical scan and spot diseases with superhuman accuracy.
Okay, so we've seen how they're all connected. But to make the difference really clear, let's put machine learning and deep learning right next to each other in a direct side-by-side showdown.
At the highest level, it pretty much boils down to two things: who's doing the heavy lifting and what kind of data are they working with. Traditional machine learning is guided by humans who have to tell it what features to look for, and it works great with structured data, neat tables and spreadsheets. Deep learning, on the other hand, is self-learning. It finds the important features on its own, which makes it an absolute master of messy, unstructured data like images, audio, and plain old text.
And this table here really lays it all out. I think the key takeaway is the trade-off. Traditional machine learning is fantastic for well-defined problems with structured data, and it needs less of it, but it needs that human guidance. Deep learning can tackle incredible complex problems with unstructured data, but to do its magic, it needs to learn on its own from just absolutely massive data sets.
All right, we've taken all the concepts apart. Now let's zoom back out. Let's reassemble the pieces and see that full picture again, putting our Russian dolls back together.
So it all comes together just like this. Deep learning is that advanced core. It's a specialized, powerful type of machine learning. And machine learning, in turn, is one of the most effective ways we have today of achieving that grand overarching vision of artificial intelligence.
What we're really seeing here is a beautiful evolution. We started with this broad, ambitious dream of AI. Then we developed a practical method to make machines learn with ML. And now we've created this powerful brain-inspired engine with deep learning that is solving problems we once thought were basically impossible for computers.
The real takeaway here isn't just about the definitions. It's about understanding that this is a progression. Each layer is building on the last, becoming more powerful and more autonomous. And that leaves us with the one really big question. As this evolution continues, as these tools get even smarter, how are they ultimately going to reshape our world?